Basic acoustic treatment and soundproofing techniques for home studios. Introduction to acoustic treatment and soundproofing. Understanding and implementing acoustic treatment and soundproofing is essential for anyone serious about home studio recording. Soundproofing involves isolating the room from external noises, while acoustic treatment focuses on optimizing the sound within the room. Both play crucial roles in ensuring a clean, professional quality recording environment. The fundamentals of soundproofing. Understanding the difference between soundproofing and acoustic treatment. Soundproofing and acoustic treatment are often confused, but they serve different purposes. Soundproofing is about keeping unwanted noise out and preventing sound from escaping the studio. Acoustic treatment, however, is focused on controlling sound reflections and managing how sound behaves inside the room. Principles of soundproofing. Soundproofing is built on three main principles: mass, air gaps, and isolation. Increasing the mass of walls, floors, and ceilings helps to block sound transmission. Creating air gaps acts as a buffer, absorbing sound energy, and isolating structures prevents vibrations from traveling through the building. Key soundproofing materials. Several materials are commonly used for effective soundproofing. Mass-loaded vinyl, MLV, is a dense material that adds mass to walls and ceilings. Multiple layers of drywall can also be used, especially when combined with green glue, a sound-damping compound that further reduces sound transmission. Other options include using resilient channels and isolation clips to decouple drywall from the studs, minimizing vibration transfer. Techniques for soundproofing doors and windows. Doors and windows are often weak points in soundproofing efforts. Solid core doors provide better sound isolation than hollow core doors. Sealing gaps around doors with weather stripping or acoustic caulk can significantly reduce noise leakage. Windows can be treated with thick acoustic curtains or additional panes of glass to improve soundproofing. Building a room within a room. The ultimate soundproofing solution is constructing a room within a room. This method involves building a secondary structure inside the existing room with separate walls, floors, and ceilings. The air gap between the inner and outer structures acts as an insulator, dramatically reducing sound transmission. Basics of acoustic treatment. The importance of acoustic treatment. Acoustic treatment is critical for creating an accurate listening environment. Without proper treatment, sound waves reflect off hard surfaces, causing unwanted echoes, reverb, and frequency imbalances. These issues can lead to poor quality recordings and inaccurate mixes. Types of acoustic treatment. Acoustic treatment is typically categorized into three types: absorption, diffusion, and bass trapping. Absorption. Materials like acoustic panels made of foam or fiberglass are used to absorb mid and high frequencies, reducing reflections and reverb. Diffusion. Diffusers scatter sound waves in different directions, helping to create a more balanced sound field and reduce the buildup of standing waves. Bass trapping. Bass traps are designed to absorb low frequencies that tend to accumulate in the corners of a room. Proper bass trapping is crucial for achieving a balanced low end in recordings. Choosing the right materials. When selecting materials for acoustic treatment, it's important to consider the specific needs of the room. Acoustic foam is effective for treating mid to high frequencies, while denser materials like fiberglass are better suited for a wider range of frequencies. For diffusion, various designs like QRD, quadratic residue diffusers, are available, which scatter sound waves more evenly. DIY versus commercial acoustic treatment. DIY acoustic treatment options are a cost-effective way to customize the studio. Building panels using materials like wood, fiberglass, and fabric allows for tailored solutions that fit specific room dimensions. For those less inclined towards DIY, commercial products offer a wide range of options, from budget-friendly to high-end solutions. Placement of acoustic treatment. Effective placement of acoustic treatment is crucial. Acoustic panels should be placed at the first reflection points, locations on the walls and ceiling where sound from the speakers first reflects. Bass traps are most effective in the corners of the room, where low frequencies build up. Diffusers are typically placed on the rear wall to scatter reflections and create a more even sound field. Implementing acoustic treatment. Analyzing room acoustics. Before installing acoustic treatment, it's important to analyze the room's acoustics. This can be done through simple tests like clapping hands to listen for echoes, or using a measurement microphone and software to assess the frequency response. Identifying problematic areas will help in strategically placing acoustic treatment for maximum effectiveness. Building DIY acoustic panels. DIY acoustic panels are a popular option for home studios. They typically consist of a wooden frame filled with fiberglass or mineral wool and wrapped in fabric. These panels can be customized to fit the room's dimensions and specific acoustic needs. When building DIY panels, it's important to use dense materials for absorption and ensure that the fabric covering is breathable to allow sound to pass through and be absorbed. Creating DIY bass traps. Bass traps are essential for controlling low frequencies, which often cause problems in small rooms. DIY bass traps are similar to acoustic panels but thicker and denser. They should be placed in the corners of the room where low frequencies accumulate. The most effective bass traps are made from rigid fiberglass or mineral wool and can be covered with fabric to match the room's aesthetics. Treating windows and doors. Windows and doors are common sources of unwanted reflections and noise leakage. Treating these areas involves both soundproofing and acoustic treatment. Thick curtains or blinds can help absorb reflections from windows. Adding an acoustic panel to the interior side of a door can reduce reflections and improve isolation. Using everyday items for acoustic treatment. For those on a tight budget, everyday items can be repurposed for acoustic treatment. Bookshelves filled with books can act as diffusers, while thick rugs or carpets help absorb sound reflections from floors. Heavy blankets or mattresses can be temporarily used to cover walls or doors, providing additional absorption. Advanced acoustic treatment techniques. Decoupling walls, floors, and ceilings. Decoupling is an advanced soundproofing technique that involves isolating the walls, floors, and ceilings of a studio from the surrounding structure. This is often achieved through the use of resilient channels, isolation clips, and floating floors. Decoupling helps to prevent sound vibrations from being transmitted through the building, resulting in better sound isolation. Floating floors. Floating floors are used to reduce impact noise and vibrations. This technique involves installing a secondary floor on top of a sound-absorbing layer, such as rubber or foam. The floating floor is not directly attached to the structure of the building, which helps to isolate sound and reduce transmission. Installing a floating floor is a complex process that may require professional assistance, but it can significantly improve the sound isolation of a studio. Using resilient channels and isolation clips. Resilient channels and isolation clips are used to decouple drywall from the studs in walls and ceilings. Resilient channels are metal strips installed horizontally across the studs, and drywall is attached to these channels, creating a decoupling effect. Isolation clips serve a similar purpose, allowing for more flexibility in installation. These techniques reduce the transmission of sound vibrations, improving the overall soundproofing of the studio. Soundproofing for specific studio spaces. Different studio spaces have unique soundproofing needs. For example, a vocal booth requires a combination of soundproofing and acoustic treatment to create a quiet, controlled environment. A drum room, on the other hand, may require more extensive soundproofing to contain the high sound pressure levels produced by drums. In these cases, using a combination of techniques, such as adding mass to walls, sealing gaps, and installing floating floors, can help achieve the desired level of sound isolation. Case studies. Practical applications. Converting a bedroom into a studio. Converting a bedroom into a functional home studio involves a combination of soundproofing and acoustic treatment. Start by analyzing the room's acoustics to identify problem areas. Soundproofing efforts should focus on sealing gaps around doors and windows, adding mass to walls, and potentially installing a floating floor if noise transmission is a concern. Acoustic treatment should address first reflection points with acoustic panels, corners with bass traps, and the rear wall with diffusers. Adapting a garage for studio use. Garages present unique challenges due to their typically larger size and hard, reflective surfaces. Soundproofing may involve adding insulation to garage doors, sealing any gaps, and installing additional layers of drywall. Acoustic treatment should focus on controlling reflections with panels, treating the floor with a thick rug or carpet, and adding bass traps to the corners. The higher ceilings in garages can be both a challenge and an opportunity, requiring additional treatment, but also offering the potential for a more spacious sound. Optimizing a small room for recording. Small rooms pose challenges due to the close proximity of walls, which can lead to strong reflections and bass buildup. In a small room, maximizing the effectiveness of acoustic treatment is critical. Bass traps should be prioritized in the corners, and acoustic panels should cover the first reflection points on the walls and ceiling. Diffusers may be less effective in very small rooms, so focusing on absorption is generally the best strategy. Conclusion: effective acoustic treatment and soundproofing are essential for creating a professional quality home studio. Understanding the differences between soundproofing and acoustic treatment, selecting the right materials, and applying these techniques effectively can transform any space into a functional recording environment. Whether building DIY solutions or investing in commercial products, taking the time to properly treat a studio space will result in clearer recordings, more accurate mixes, and an overall better experience for both creators and listeners.